Okay, this week we're going to begin by monitoring the weather or just learning about what weather really is. So take a look at that first, shall we? So what are some of the basic characteristics of the atmosphere and weather? So weather, if you looked outside right now or walked outside or even inside, it's what you feel. It's the temperature, humidity, clouds, precipitation, wind speed, wind direction. Each of those makes up the weather. And weather is what's here and now. So if I came up to you and asked you what the weather is, you would tell me what's going on right now. Now, if I ask you for a weather forecast, that may be sometime in the future. So all of these variables change constantly. And meteorology is just the study of that. Climate, we look at weather over long-term averages, 30 years or more. And climatology is just the study of climate. What controls our atmosphere so that we stay in certain boundaries. So one of the things you're going to talk about is time zones in this course. Most weather, in order to keep an accurate image of what the weather is around the world, we use a time zone over in England called Zulu Universal Time. Basically, the East Coast is 5 hours on Eastern Standard Time away from it. And you can see how the times change. One of the key aspects of weather, we want to know the weather at one moment in time because weather's constantly changing. So in order to do that, if we took an observation in Sacramento, California at exactly the same time, 4 a.m. there would be 7 a.m. at New York City, for example, and we took those two observations and looked at them, that would give us an idea of what the weather is over a larger area. So we're trying to do this over the whole globe. So yes, when I tell you I look at the time is 18 Zulu, which would correspond to 2 p.m. in the eastern United States. So, but that is all the same time over the whole world. There are two basic types of pressure systems. There is high pressure and low pressure. High pressure generally brings good weather, low pressure, bad weather. And if you look at the winds flowing around them, you'll notice that high pressure kind of has clockwise flow, winds flow outward. Low pressure has counterclockwise flow, winds flow inward. And then there are the air masses. We saw a front there on the last image. And these fronts divide air masses. There are cold air masses like we had the other week, several weeks ago, right before Christmas, when it got bitter cold. And then there are warm air masses like we're had here in the last few weeks. And some of them are humid, some of them are very dry. And warm air is lighter than cold air. So that means it will rise up over cold air. So when you have a cold front coming down, it pushes the warmer air out ahead of it upwards, and you might get some precipitation. The same token, if a warm air is moving up, we have warm air overriding the cooler air to the north, for example, maybe causing some light rain. So one of the things we look at is temperatures. I bet most of you are curious on the temperature when you walk outside in the morning. I don't think you'd be wanting to dress in shorts when it's 10 below zero. By the same token, I don't think you'd want to wear a winter jacket when it's 90 degrees. So temperature is something we all kind of at least sense a little bit about. The minimum temperature usually occurs around sunrise, and the maximum temperature occurs in the mid-afternoon. Yes, the sun reaches its strongest at noontime, but the sun's still shining. So that allows the temperature to continue to go up for a while. Dew point, measure of air, but it's basically the point is if I cool the air you're in right now, when frost would form. Relative humidity is how moist the air is. Precipitation, we look at amounts in tenths of an inch. Yes, we use English units in this course. make life easier for you mostly. Air pressure. Air pressure is the weight of the air. We're going to talk about that. Winds blowing, direction and speed, sky cover. And there are various weather watches and warnings the National Weather Service and others issue. Clouds. I love to look at clouds, and they can tell you a lot about what might be happening in the weather. Fog is just a cloud in contact with the ground, for example. And stratus clouds kind of form when a warm front is moving through your area. That little bit of cooler air it's displacing, and that warm air aloft kind of forms cirrus clouds way out ahead of it. Then they become lower, and eventually they become more stratus clouds. And when they begin to rain, they may become nimbostratus clouds. Cold fronts, a little steeper. They push the air up a little faster, and we wind up getting cumulonimbus clouds. And the clouds at any elevation can be moving in different directions. That's because the atmosphere is three-dimensional. So the winds can move to the left or to the right, or maybe from the north or from the south, anywhere in the atmosphere. So I wanted to look at just a weather map. And the main reason I wanted to do this was because you're going to be your first thing you're going to learn as far as labs go is to look at a surface weather map. We're going to spend some time in that the next couple of weeks. So let's just look. Each point plotted here is a weather observation at that point. You're going to learn what each part of that observation is. Here's temperatures in the upper left, dew points in the lower left. The wind is a barb. And in weather, in meteorology, we take the wind as where it's coming from. Notice the barb points on the north side coming towards the south. So that means it's a north wind. That means the wind is coming out of the north, and north of that area is Canada, so probably a colder wind. And these little barbs on it indicate how strong the wind is. Notice that just has one barb on it. We can go out to other areas and we can see more barbs. Let's just go across the country for a minute here. We know there's a big low off of the California coast right now. And with that, notice all those other winds counterclockwise around the low. So what we've just talked about, counterclockwise winds. And these winds are out of the south. Here's two barbs, which is 20. That's about a 22-mile-an-hour wind. 20 knots is what that would be. Oh, yeah, all these symbols in the middle that are covered in, that means the sky is cloudy. Here's where you'd see no cover. That means the sky is clear. So if you were standing at this point here in Oregon, you would have a temperature right now of 53, a dew point of 40. A little bit of clouds, but not much. No wind. And finally, the atmospheric pressure. What's the atmospheric pressure? 0.95. Oh, yeah, we bring the atmospheric pressure down to sea level for everywhere. Obviously, there's mountains and all, but I can't draw a map of pressure if I have pressure at the top of a mountain and the pressure in the valley. It would not make sense. So what you see here is 0.93. So the first two digits are left off on this one. It's 1009.3 or 1009.3 millibars. Now, if that number here is greater than 500, the odds are there's a 9 in front of it, and it might be 9640 or 964.0. So you can see the difference. Pressure, I mean, think about it, 964.0 versus 10,009.3. That's not a huge range in pressure, really. So this is just giving you an idea. Pressure lines are drawn here. You're going to be drawing some in your first one. Just follow the contours. Know where all the pressures on one side should be lower than all the pressures on the other side. I hope you got a little bit out of this. If you have any questions, please don't hesitate to ask.